Ever wondered why square root of 18 is reduced to 9 times 2 instead of 6 times 3, where square root of 9 times 2 will still give you square root of 18 and square root of 6 times 3 will still give you a square root of 18? Well, that's what we'll be looking at in today's video. Hi, my name is Faithful and welcome to Alpha Space, where we simplify maths, physics and chemistry for students like you. In today's video, we'll be looking at reduction of surds to their basic form. Sit back, relax while we dive into this video. Now, square root of 2 is in its reduced form because it does not contain a factor, which is a perfect square. Before we dive into the reduction of surds to their basic forms, let us quickly explain these two keywords I just mentioned. The first one, which is what? Factor, and the second one, which is what? A perfect square. Now, what is a factor? A factor is a number that can divide a number without what? A remainder. So the factor of a number is a number that can divide that number without what? A remainder. For example, if you have 4, a factor of 2 or 4, would be what? 2. Another factor is what? 1 also. So 1 and 2 are factors of 4 because what? 4 divided by 2 is equal to what? 2. 4 divided by 1 is equal to what? 1. So 4 can divide 2 without a remainder. Therefore, 2 is a what? Factor of 4. The next thing I would like us to also know is a perfect square. Now, what is a perfect square? A perfect square is a number you get when you multiply an integer by itself. What is an integer? Integers are positive and negative whole numbers. Now, 1 squared, let me do it this way. 1 squared is equal to what? 1. 2 squared is equal to what? 4. That means 2 times 2. 3 squared is equal to 9. 4 squared is equal to 16. You can write 5 squared to be equal to what? 25. All these numbers 1, 4, 9, 6, 25 are referred to as what? Perfect squares. So these terms, the understanding of these terms will help us in what? Reduction of surds to their basic forms. So let's briefly look at examples. So examples that will make us to understand all these terms we have talked about. So as you can see, we are given to simplify the following. That means we are asked to reduce them to their basic forms. So the first one we have is reducing square root of 50 to its basic form. Now, square root of 50 can be written as, the most obvious one that will come to your mind will be 10 times 5. Now, if you make it to be what? 10 times 5, we cannot follow through this route. Why? Neither 10 nor 5 is a perfect square. And recall, as we stated, a perfect square is a number when formed when two integers multiply themselves. So it's a number that's got to when two integers multiply themselves. There is no number that will there's no integer or whole number that will multiply itself twice that will give us what? 10. So therefore, what it therefore means is this term is not possible. So the first thing you do is what? Trying to figure out factors of 50. The first factor of 50 you can get will be 2. Now, 2 times what will give us 50? 25. Is 25 a perfect square? Yes. So therefore, we'll make this to be what? 25 times 2. Since 25 is a perfect square, based on our multiplication rule, if you have not watched that video, you can go and check out the video I just made on surds from the beginning. So you can watch surds, the first video I made on surds, you can watch it and you'll be able to understand this rule I'm going to take. So based on your multiplication rule, you can make this to be what? Square root of 25 times square root of 2. And my final answer will be square root of 25 is what? 5. And square root of 2 times square root of 2. And this will be our final answer. So let's work with this one. The second question asks us to simplify square root of 12. Now, what is square root of 12? The first factor is 1, obviously. The second one will be 2. 2 is a factor. And since 2 is a factor, we can say square root of 6 times 2. Now, is 6 a perfect square? No, because there are no two integers that will multiply themselves to give us what? 6. So therefore, 6 cannot work. Obviously, 2 will not be able to work because 6 times 2 are the only numbers that 2 can only multiply 6 to give us 12. So what other number can we use? 3 is also a factor of 12. Since 3 is a factor, we can put 3 here, and 3 times 4 is what? 12. So therefore, 4 times 3 is equal to 12. And since 4 times 3 is equal to 12, is 4 a perfect square? Yes, 4 is a perfect square. So therefore, we can say square root of 4 multiplying square root of 3. And our final answer will be what? Square root of 4 is what? 2 square root of 3. And this is the reduced form of what? Square root of 12. The final one will be what? 80. The final one will be 80. Now, square root of 80 is what? I said square root of 80. 80 can be written as 10 times 8. Is 10 a perfect square? No. Is 8 a perfect square? No also. So therefore, we are going to figure out numbers that can work with it. Now I'm going to do this alongside with you. If you are with your calculator, you can bring it out. If you are with your calculator, you can bring it out. Now, the first factor we can have for 80 is what? 80, if you try 2, it will give you what? 2 times 40, which is 80. Is 40 a perfect square? No, 40 is not a perfect square. What other number can you think of? Let's try 5. Now, 5 will give us what? If you are with your calculator, you can be punching it. 5 will give us what? 16. That means 80 divided by 5 is what? 16. Since 5 is a factor, is 16 a perfect square? Yes, 16 is a perfect square. So therefore, we can write this to be what? 16 times 5, obviously, and we can say square root of 16 times square root of 5, and the final answer will be what? Square root of 16, which is what? 4, and times square root of 5, so it will be 4 square root of 5. And this is the reduced form of square root of 80. This is how you reduce surds into their what? Basic forms. So I'm going to give you one. I'm going to give you one to solve by yourself. I'm going to give you one to solve by yourself. Do square root of 72 and get back to me. So you can do this. You can drop your answers in the comment section. I will do well to reply you. Now, there is something I want us to know. If I'm giving the expression square root of 5 to reduce to its basic form, is there any factor in this number that does not have that is a perfect square? I mean, is there any factor in this number 5 that is a perfect square? No, because you can only do 5 times 1. So therefore, square root of 5 is already in its reduced form. So there is no need of reducing this to any other form. Thank you very much. We'll be looking at addition and subtraction of surds. So briefly looking at addition and subtraction of surds, I believe we have all watched the video I made on addition, on rules of surds. So we are all aware of this. If you have not watched it, you can pause this video, go back and watch the video I made on the rules for surds. There are 10 rules for surds I made, and I want us to be familiar with them. So if you are familiar with it, then we can proceed to this question. Now there are 3 questions we'll be solving in this segment. So this will be the first one. The first one is asking us to solve this expression involving square root of 50, square root of 18, and square root of 32. Now, I believe we are all familiar with it. on the aspect of reduction of surds to their basic form. So first of all, before performing this, recall in the video I made on surds, the first video I made, I stated that before we add and subtract surds, they must be, the terms within the square root must be the same. They must have like terms in the square root. So the terms with the square root must be the same. Now, in this expression, you can see they are not the same. What it therefore means is, looking at this expression, we can reduce this expression to their basic forms. So let's first of all reduce square root of 50. I believe we have done it, but I'll still go over it again. Can be written as what? 25 times 2. Why? Because 25 is a perfect square. We can also write it as 10 times 5, but neither 10 nor 5 is what? A perfect square. But 25 is a perfect square. So we can write this as what? 25 times 2, which is equal to what? 5 square root of 2. We all know we've got it. Square root of 25 is what? 5. Now square root of 2. So this is the reduced form of square root of 50. The reduced form of square root of 18 is what? 18 can be written as 6 times 3. Neither 6 nor 3 is a perfect square. It can also be written as what? 9 times 2. 9 is a perfect square. So therefore we can write this to be what? 9 times 2, which is equal to what? Square root of 9 is what? 3. So it will be square root of 9 multiplying square root of 2, which is equal to what? 3 square root of 2, because square root of 9 is equal to what? 3. Now this is the reduced form of square root of 18. Now for square root of 32, can be written as what? Square root of what? 16 times 2. Now what is square root of 16? Square root of 16 is 4, obviously. So we write square root of 16 times square root of 2 is equal to what? 4 square root of 2. Now these are all the reduced form. These are all the reduced form of this equation, this expression we're given. So we can now put it back. We'll have 5 square root of 2 minus 3 square root of 2 plus 4 square root of 2. Now we can work with this expression. Why? Because the terms within the square root are all what? Like terms. So they are all the same. So what it therefore means is I can now use board mass. And in your board mass, you can see that what? Addition comes before subtraction. So we can add these numbers, then subtract with this one. So we have 5 square root of 2 plus 4 square root of 2 minus 3 square root of 2. And based on our addition rule that we stated, we'll add these two terms together. So it will be 5 plus 4, which is what? 9 square root of 2. Now minus 3 square root of 2. And our final answer will be what? 9 minus 3 square root of 2. And final answer will be 9 minus 3, which is what? 9 minus 3, which is 6, to the square root of 2. And this is our final answer. So this is the simplified version of this expression. Let's look at the second question and we'll see how we'll solve it. Now we are asked to simplify this. Now, in order to simplify it, you can see we're only subtracting here. What it therefore means is the terms within the square root must be like. They must be like terms, and they are not like terms. So what it therefore means is we have to reduce them. In order to reduce square root of 112, you already know that 2 is a factor, and 2 times 56 is what? 112. But is 56 a perfect square? No, 56 is not a perfect square. What it therefore means is you can say this to be what? 2 times 56, which is not a perfect square. So the next term will be what? 4. And 4 times 28. 24 is a perfect square. So what it therefore means is we can have here to be 4 times 28. And our final answer will be what? Square root of 4 times square root of 28. We will now have what? 2 square root of 28. Now we have to reduce square root of 28. Square root of 28, we cannot do it. We cannot reduce this to its basic form. We can only have 28 times 1. And obviously 1 is a perfect square. So we can say 1 times 28. And we can say square root of 1 times square root of 28. And our final answer will be, well, square root of 1 is 1. So it will be 1 square root of 28. But no need of writing this 1, because only square root of 28 signifies that we have only 1 square root of 28. So we can now put this into the equation. We can now say the expression, we can say 2 square root of 28 minus square root of 28. Finally, we can say, if I say 2 minus 1, because this square root of 28 are like them, so we'll bring out 1. So it therefore means is, this is the same thing as me saying 2 minus 1 square root of 28. And 2 minus 1 is 1. So we can have 1 square root of 28. But there is no need writing the 1. So our final answer is what? Square root of 28. Now, I want you guys to solve this question. I'll write it here. I want you guys to solve this question. This one will be square root of 72 minus square root of 8. Solve this question and drop down your answers in the comment section. I'll do well to what? Reply each and every one of you. So let's look at the last question before we look into what? Conjugate surds. Okay, so we have this to work with. What we're dealing with now is square root of 27 is equal to minus square root of what? 12. And we have to simplify this expression. Before simplifying it, we have to make this to be what? One standard expression. So what we'll do is carrying square root of 12 to the other side, and to the left hand side. So we have square root of 27 will be what? Plus square root of what? 12. Now since we have this like this, what it therefore means is it is equal to what? We don't know yet. We can now say what? Square root of 27, reducing it, will give us what? 3 times 9. Or better still, writing it in a better fashion will be what? 9 times 3. Is 9 a perfect square? Yes, it is. So we have square root of 9 times square root of 3. And our final answer will be what? 3 square root of 3. This is the reduced form of square root of 27. And we have done square root of 12 before. So I'll just go directly into it. 4 times 3. Obviously 4 is the perfect square. So we can say square root of 4 times square root of 3. Our final answer will be what? 2 square root of 3. Now putting it into the expression, we can say 3 square root of 3. 3 square root of 3. 3 square root of 3 plus 2 square root of 3 is equal to 3 plus 2 all square root of 3. And our final answer will be 3 plus 2, which is 5. 5 square root of 3. And this will be our final answer. Practice more questions on reduction of surds, their basic form, and addition and subtraction of surds. So let's look at what? Conjugate surds. We'll be looking at conjugate surds. Now, if you have a surd expression a plus square root of b, its conjugate is what? Its conjugate is a minus square root of b. This is the conjugate of this expression. If you have another expression, let's assume minus 3 square root of 2 plus, we can use plus square root of 7. Its conjugate is what? Not plus 3, but minus 3 square root of 2 minus square root of 7. What it therefore means is whenever you want to do the conjugate of a surd expression, it is only the sign that is separating those two surds expression that is its conjugate. So let's assume you have square root of 7 The conjugate of square root of 7 is what? Square root of 7, because there is no sign separating the two of them. So let's look at what? Examples concerning them. But there is something I want to tell you about. When you have an expression a plus square root of b, and its conjugate is what? A minus square root of b. The product of these two will be what? A squared minus b. What it therefore means is this. A times a is what? A squared. A times b will be what? Minus a square root of b. Square root of b times a will give me what? Plus a square root of b. And plus times minus will give me what? Plus square root of b times minus square root of b. Recall from the first video I made on surds, I told you that whenever we have two surds multiplying each other and the terms are the same, the square root will cancel. Plus times minus is what? Minus, so it will be minus b. And minus a square root of b plus a square root of b will cancel each other and gives us what? Our final answer here. Now, whenever you are solving questions involving sorts and you want to rationalize them, because we only do the conjugates whenever we want to rationalize expression. You only rationalize the expression of the denominator. So for example, if I have this, if I say square root of 2 plus square root of 7 divided by square root of 3 minus square root of 5. If I want to rationalize this equation and I'm asked to simplify an expression like this, I will multiply the denominator and the numerator by its conjugate. Now, the conjugate obviously will be square root of 3 plus square root of 5. Now, if I assume maybe there is no such expression here, and I have an expression, let's assume I have an expression 2, I will not rationalize this with its conjugate. Why? Because there is no such expression in the denominator. So what I'm trying to explain is this. Whenever there is a such expression in the denominator of a question, of an expression, that is when you rationalize. We only rationalize the denominator and not the numerator. So let's look at examples and you will understand all this I have just said better. So we're asked to simplify all these questions. Let's start with the first one. Without much wasting time, let's do this. We have 1 all over 3 minus 2 square root of 2. Now, what will be the conjugate of this? I'll write it here. The conjugate of this will be what? 3 plus 2 square root of 2. So I'm going to multiply the numerator and the denominator by it. 3 plus 2 square root of 2 all over 3 plus 2 square root of 2. Now, this times 1 will obviously give me what? 3 plus 2 square root of 2 all over. This will be in brackets, this will be in brackets. 3 times 3 is what? 9. 3 times 2 square root of 2 will be what? Plus 6 square root of 2. And this times this will be what? Minus 6 square root of 2. And this will be minus 2 times plus 2 give me what? 4. So negative 4, square root of 2 times square root of 2 will give me what? 2. So it will be 4 times 2, which will give me what? 8. 4 times 2, which will give me what? 8. Now, recall from that shortcut I told you that we are going to have a squared minus what? B. A squared minus b. So obviously, plus 6 square root of 2 minus 6 square root of 2 will cancel each other because it will be 0. So our final answer will be what? 3 plus 2 square root of 2, 9 minus 8, which is what? 1. So all over 1. And therefore, our final answer will be here. Let me write it here. 3 plus 2 square root of 2. And this will be our final answer. So let's solve this. For this, I have 1 all over 1 minus square root of 3 all squared. Now, I won't just go into solving this by finding its conjugate, because we can't even find the conjugate of this because it is squared. So what it therefore means is we have to open the bracket. So if we are to open the bracket, we have 1 minus square root of 3, 1 minus square root of 3, because it is all squared. So 1 times 1 is 1. 1 times minus 3 is what? Minus square root of minus 3. Minus 3, minus square root of 3 times 1 will give me what? Minus square root of 3. And minus square root of 3 times plus square root of 3 times minus square root of 3 will give me what? Plus 3. Because based on the multiplication, when they are like terms, they will cancel out each other and bring out the term. So it will be 1 minus square root of 3 minus square root of 3. It's the same thing as me saying minus 1 minus 1. When I'm owing one person, let's assume the negative to be what? Owing. When I'm owing, let's assume I'm owing my brother and I'm owing my sister. How many people am I owing? I'm owing 2 people. So what it therefore means is minus square root of 3 minus square root of 3 will be what? I'm owing 2 square root of 3. I'm owing 2 square root of 3 plus 3. Now we can add this. 1 plus 3 is what? 4. So I can say 4 minus what? 2 square root of 3. Now, this is what I can put in the denominator here. So let us now put it here and be able to what? Rationalize it by finding the conjugate. And therefore, you all know that the conjugate now will be what? 4 plus 2 square root of 3. So let us now use this here before multiplying the numerator and the denominator by its conjugate. Okay, since we all know this to be 1 all over what? 4 minus 2 square root of 3, we can multiply it by the numerator by its conjugate, 4 plus 2 square root of 3. Multiply the denominator by its conjugate, 4 plus 2 square root of 3. Since we have it like this, what we'll therefore do next is what? This times 1 will give us 1, so 4 plus 2 square root of 3 all over 4 times 4 is what? 16. 4 times plus 2 square root of 3, obviously to give us 8 square root of 3, minus 2 times 4, 2 times minus 2 square root of 3 times 4 will give us what? Minus what? 8 square root of 3. And obviously this will give us 0. So there's no need writing it here. You can just say minus 2 square root of 3 times plus 2 square root of 3. And based on our multiplication rule, we do it like this, times 2 square root of 3. What we'll do is minus 2 times 2 will give us what? Minus 2 times 2. Obviously, square root of 3 times square root of 3 will give us what? 3. So here will just be 3. So minus 2 times 2 will give us negative 4. Negative 4 times 3 is going to give us what? Negative 12. So we are going to have negative 12 over here. Now, since we have it like this, our final answer, let me draw this line here. Our final answer will be what? 4 plus 2 square root of 3. 16 minus 12 is what? 4. So our final answer here will be 4. So this will be my final answer. You can go a step further. If you want to simplify it more, you can say 4 over 4 plus 2 square root of 3 over 4. You can do it this way. It is the same thing, because if I take the LCM of both of these numbers, I will have this. So 4 divided by 4 is what? 1. So I have 1 plus 2 here. 2 into 2 is 1. 2 into 4 is what? 2. So I'll have the root of 3 all over 2. And this will be my final answer. I think it's preferable you do it like it's just like when your wardrobe is not organized, you organize it. So this is more organized than this. So it is best to leave it like this. So solving the last question, we have square root of 2 plus 1 all over square root of 2 minus 1. So since we have this, we all know the conjugate to be square root of 2 plus 1. So we'll multiply the numerator by square root of 2 plus 1 all over the denominator square root of 2 plus 1. Now in mathematics, a squared minus b squared is the same thing as a minus b, in brackets, let me do it here, somewhere bigger, so I'll be able to understand it. A squared minus b squared is equal to a minus b, a plus b. Now this is a minus b, and this is a plus b. So whenever we want to multiply these two together, we don't need to go through the lengthy process of multiplying them one by one. We can do it here, obviously. And do it here. Square root of 2 times square root of 2 is what? 2. So we have equal to 2. Square root of 2 times 1 will give me what? Plus square root of 2 plus square root of 2 plus 1. Now, since you're supposed to give me a squared minus b squared, a squared is the same thing as me saying square root of a all squared. Recall from the rules of sorts that we did. If you have not watched that video, I urge you to go back and watch it. This will cancel this, obviously, and this will be 2. So obviously, this will be 2 minus square root of square of 1, b squared, which is what? 1. So my final answer obviously will now be this. 2 plus 1 is 3. Square root of 2 plus square root of 2 is what? 2 square root of 2. And 2 minus 1 is what? 1. So all over 1. And my final answer will just be 3 plus 2 square root of 2. And this will be my final answer. Thank you very much for watching this video. Do well to practice more questions, and you will see that these sorts or sorts in general are very easy. See you in the next video.